Welcome to Spacecraft Guide, the channel that goes over the most iconic spacecraft in the world. How did the astronauts know that they had power to the reaction control system, the system that maneuvers the spacecraft, like going to dock with the International Space Station? How did they know that the system was working so they didn't have problems like the Boeing Starliner where they might have issues with the thrusters? Well, we're going to go over that in this episode. And for the Patreon subscribers, if you are a Patreon subscriber, we're going to go into the schematics of how this works. And if you are a paying Patreon subscriber, we're going to go even deeper into the system. Yeah, that's right. This episode, we're going to talk about the aft reaction control system helium talkback switch. And when you click on it, it takes you to the aft reaction control system helium talkback page. And here you can see that the talkbacks are right here. And what they do is it shows open or closed when that pair of valve is open or closed, and barber pull when the valves are in transit, or one valve is open and the other is closed, or for some microswitch failures. So this right here is going to tell you if you opened or closed that valve. Now, when both valves, the helium and fuel oxidizer, are open, the talkback indicates OP, open. When both valves are closed, the talkback indicates closed, which we don't have here. And if the valve is open, if one valve is open and one is closed, the talkback indicates the barber pull. So what it's going to look like is it was in the video up here that we had before. It's going to be a line that comes across, and that means that the valve is in transit or it's not operating correctly. So why do we have this here, and what does it mean? So what if we have helium? What does that helium do? Well, the helium is an inert gas, which means that it doesn't react with anything. So if you mix these two together with the oxidizer, it won't start any kind of explosion. The same with the fuel. It doesn't react with it. But what it does is it acts as a pressure to push, like you see the helium here is on top of the oxygen. That is, the helium is pushing the oxygen through. So even though there is some kind of a pressure here with the oxygen when the tank is full, when it gets less full, this helium enters the system and pushes that oxidizer through the system. And this will tell you that yes, the helium is pushing it through. So the helium is very important because it acts as the engine, as the pump. Let's just say, pump creates pressure. Well, here the helium is the pressure, and that's what makes this system work. And that's why it was important that the helium system worked on the Starliner or also with the SLS. If there's leaks from the helium, you're losing helium, that means you're going to lose some of your power, the pressure that's going to push the oxidizer and the fuel into the engines and the thrusters. So that's what we have for this week. That answers your question. Now for our Patreon subscribers, even the free one, and again, doesn't cost you anything, we're going to go deeper into this system to show you the schematics, how it works. So if you click on schematics, is the book Flying the Space Shuttle, A Pilot's Guide to Orbital Flight, Digital Autopilots, and Spacecraft Navigation. Now, this book is actually, the text itself has been sent into outer space as part of a documented test of electronic information integrity in the space environment. And this is the original source manuscript whose text was intentionally selected, prepared, and transported beyond Earth's atmosphere as part of a documented spaceflight data integrity experiment. So you can actually check out this book here and see it. You can read a sample. If you come down here, read a sample. This will be what you see. So you can actually go through. What I have in here is
the first chapter, and it is going to explain what the instruments are on the space shuttle and tell you what each component is. Now, the first chapter goes over very quick summary of what the instrument is. If you go into the book further, you can see on the chapters here that you go into the parts, the aerometers, the rate indicator, all of that you will be able to look at in the book. But right up to here, you get to display on, or you get to view on the Amazon site, and the text that we put onto the spacecraft and launch goes all the way down to chapter 4. That's as much information as I could squeeze into my space that I was allowed to into the satellite or into the rocket that went into outer space. And this is my certificate that tells it that it went into flight. Now, on October 27th is when I loaded it onto the rocket, and it went up into space later in November. And one of the great things down here is if you scanned it with your computer, you can see the text that was actually sent into outer space, and it'll be in identical to the book, except there might, or there is in the text, it says test flying. It's my first book in space, test flying the space shuttle. Now, the reason I did that is to document. So, to the author's knowledge, this marks the first publicly documented case in which the original manuscript of an Amazon Kindle ebook served as the primary text source for a recorded outer space transportation prior to its publication. Well, this was the source document, so this is before the publication of the next book that I'll have out. This is the original source document. And again, right here, if you click on Read a Sample, you can actually look and see the contents of the book even before you buy it. And it goes over Chapter 1, the primary flight display, which is basically an overview of what the astronauts see when they're flying the shuttle. And it's pretty similar to what they fly on SpaceX or the Artemis rocket that goes into outer space that is going to go to the moon coming up in February of 2026. So if you want to see that, you can come down here, or you can see and read about those instruments here.